Hi guys, today we are going to talk about logarithms. Let's start with a simple example. We know that 2 to the power of 3 gives 8. Now, we can write this in a different way. We can say that the logarithm with base 2 of number 8 is 3, as 2 to the power of 3 gives 8. Remember this circle here. Generally speaking, we can write logarithm with base a of number theta is x, as a to x to the power of x gives theta. We can write this equivalently, a to the power of x gives theta. Remember that this number here, a, must be greater than 0 and different than 1. Also theta here must be greater than 0. Now let's get to some exercises. Let's try some exercises. Well, try to find logarithm of 16 with base 2. Now pause the video here and try to find the answer. Okay, if you couldn't find the answer, or if you want to check it, this is 4, as 2 to the power of 4 gives 16. Now, we saw earlier that log, we can simply call this as log with base 2 of 8 is 3. Now try to find the log 2 of 1 with base 2 of the number 1. Pause the video again and try to find the answer. Okay, this is 0 because 2 to the power of 0 gives 1. We can write this equivalently, 2 to the power of 0 is 1. Let's get to another example. Try to find logarithm with base 2 of 0.5. Okay, pause the video and try to find the answer. This is minus 1. Why? Because 2 to the power of minus 1 gives 1 over 2, which is 0.5. As we can see, in this case, the result is negative. This happens every time if this number here is less than 1, but always greater than 0. This gives a negative example. Okay, sorry. Now let's get to some properties of logarithms. Now, the first property, log 2 of 2 to the power of 3. We can say log 2 of number 8. As we saw earlier, this is number 3. Notice here that these two numbers are the same. In this case, the result is this number here. Generally speaking, log a to the power of x is x. As these two numbers here are the same, the result is always x. This is the first property of logarithms. The second property, 2 to the power of log 8. This is 2 to the power of 3, which is 8. Sorry, note here that these two numbers here are the same. Generally speaking, a to the power of log a x, and these two numbers are the same, gives x. These are the two basic properties of logarithms. Now, generally in practice, we use two types of logarithms. The first one is with base 10. The first type, base 10. Logarithm with base 10 of theta is x, as 10 to the power of x gives theta. 10 to the power of x gives theta. We usually write this in a simpler way without writing down the number 10 here. We simply write log of theta equals x. Now the second type is the natural logarithm. The natural logarithm has base e, Euler's number. So log with base e of theta is x. Equivalently, we write e to the x is theta. So this logarithm here can be written in a simpler way, ln of theta, and is called natural logarithm. We do not write the number e here. Sorry. Now let's get to laws of logarithms. Okay, I'm going to present the laws of logarithms using examples. First law. Now, log 2 of 8 plus log 2 of 16. This we saw earlier is 3, and this is 4, as 2 to the power of 4 gives 16. The result is 7. Now, what happens if we multiply these two numbers? Log 2 of 8 times 16. 8 times 16 gives 128. So, what is the result here? This is 7, as 2 to the power of 7 gives 128. So what we see here is that the addition becomes a multiplication in a way. So the general law here is this: log ax plus log ay equals log with base a x times y. Sorry, this is the first law of logarithms. Let's get to the second law. Well, now the second law. As an example again, we give log 2 of 32 minus log 2 of 8. This is 5, as 2 to the power of 5 gives 32. And this is 3, so the result is 2. Now, what happens if we turn this into a division? Log of 2 of 32 over 8. We divide these two numbers. Log with base 2 of 4 is 2, as 2 to the power of 2 gives 4. So what we see here is, in a way, that subtraction becomes a division. So the general rule is this, the general law: log ax minus log ay is log ax over y. This is the second law. Okay, let's go to the power law. The third law. The third law is this: try to find log 2 5 to the power of 3. This can be written as log 2 5 times 5 times 5, which is, according to the previous rule, addition to multiplication, or multiplication to addition. It becomes log 2 5 plus log 2 5 plus log 2 5, which is 3 times log 2 5. What we can see here is that this number here goes before logarithm. Just look at that. So the general law is this: log a theta to the power of n becomes n times log alpha theta. This goes before the logarithm. And the last rule is the nth root rule. Okay, let's start with an example. Log 2 of cubic root of 5 to the power of 4. Cubic root of 5 to the power of 4. Another way to write this root here, as we know from algebra, is this: 5 to the power of 4 over 3. So this number, as we saw earlier, goes before the logarithm. So we have 4 over 3 log 2 of 5. So the general rule, the general law is this: nth root of theta to the power of m becomes m over n log alpha theta. Okay, thank you for watching this video.